So the first zeroth law, got a pen that's too big here, was delta S equals V delta T. The second zeroth law was delta V equals A delta T. Ask you something about this. So both of these equations describe the motion of an object, or they could describe the motion of an object. There's something in these equations that they have in common. In fact, there's something in these two equations that is, in fact, identical. What is the same? Change in time is the same. The time that it took to change position is the same time that it took to change speed. So we have this feature of delta t equals delta t. So it is the case that the delta t, I gotta write what I'm saying. We'll call this delta ts, and we'll call that delta tv. So delta ts equals delta tv, which means that delta s per v equals delta v per a, which means ADS equals v dv, and I want to be particular here. It does happen to be the case that I'm dealing with average speed here. So I'm going to go back and put that in the box. New equation. In fact, this is called the zeroth. I'm going to rewrite my z there. Zeroth law theorem. So a theorem, okay, or the ZLT, we'll call it. A theorem is when you pull two things together to create a new thing. That's the hillbilly definition of a theorem. You can look up theorem if you want. But we didn't derive the zeroth law theorem from a first principle, though we could have. We could have said every change in position and every change in speed require a change in time, and we could develop it. And I have a handout I'll give out later for that. It's more complicated than this. So here's another equation. If I know 3 out of 4 things, then guess what? I can get the other 2. And in fact, if I know the change in speed, then I know that the average speed is half the change. And if I know the average, I know that the change is double that. So I actually can reduce the number of pieces of information that are required. If I know anything about speed, I know the rest of the story about speed. And so I only need 2 out of 3 things, actually, in this one to get the other parts. Now, the zeroth law theorem does not appear in any textbooks. The first zeroth law and second zeroth law do appear in textbooks. Unfortunately, they don't name it properly because they haven't talked to me yet. I'm trying to not be bitter about that, but I'll get over it. Zeroth law theorem, nobody writes it this way. I've never seen it written this way in a textbook. What I have seen, and you probably too if you've done any reading, is instead of ADS equals V bar dV, what they do is they expand this out. So hopefully you recognize that this bit right here is where this comes from. And then if you multiply, both sides by 2, And so there is this equation that is typically given this way. This shows up in textbooks. It's the same thing, just expanded out. There's more computational steps involved when you use it, but it is a useful equation. But the storyline on this equation is the same as the storyline on the Zeroth law theorem. The story in the Zeroth law theorem is every change of position and every change in time always requires, every change in speed and every change of position always require change in time. That's the storyline on the Zeroth law theorem. This is just an expansion of the Zeroth law theorem. Same storyline, just not as straightforward symbolically. So Zeroth law theorem, one more equation that we could add to our other list. So on your other piece of paper where we were listing equations, I would write this equation and ADS equals V bar dV. Certain situations will lend them to the Zeroth law theorem that I gave. Others will lend themselves to the way that you typically find in a textbook. All right. But the thing that I want to emphasize is we are now up to generating, I don't know, we're on our way to a dozen equations of motion, 10, 12 equations, whatever we listed. And it began by the fact that everybody can recognize that no object can change position instantly. Every change of position always requires a change in time. That's where we started with this. And we built the first and second zeroth laws out of that basic fact of life. Then algebra lets us expand those two laws into multiple equations that will prove useful. We reproduced those things again by graphical analysis, which led us to two new equations and a new understanding about one of the old ones. And then when we realized, hey, both of these laws involve the same time interval, now there's a new equivalence, what leads us to another way to describe motion. And this one is independent. This is not just independent of time. There's time isn't even relevant. I don't need to know anything about time directly. If I know speed, acceleration, I can get position. If I know position, acceleration, I can get speeds, et cetera, et cetera. All right. So lots of equations that come out of the box because we recognize no object can be in two places at the same time. So ponder that.